Assalamu alaikum, dear students. Yesterday we discussed about the definition of ellipse. Today we are going to discuss about the standard forms or the standard equations of ellipse. Now, firstly, we will define what is eccentricity of an ellipse. The eccentricity of an ellipse is the ratio of the distances from the center of the ellipse to one of the foci and to one of the vertices of the ellipse. It is denoted by E. Now let us suppose that the major axis of this ellipse is on the x-axis. This means that the both the foci lies on the x-axis. That is, here F is the foci, one of the foci of this ellipse. Then by definition, eccentricity is the ratio of the distances from center of ellipse to one of the foci. Here distance of the focal point, this focal point F, from the center is C, and a distance between the center and the vertex, here this is the vertex, is A. Because the major axis, semi-major axis is A, this means that E equals to C by A is the number which is called as the eccentricity of an ellipse. Here this eccentricity is always less than 1 because this C is less than A. So in this way we define the eccentricity of an ellipse. Now we will derive the standard equations of an ellipse. If center is if center is origin and the foci lies on the x-axis, then the ellipse is of the form of this. Its major axis is 2a, minor axis is 2b, while this minor axis lies on this this y-axis. Distance of a foci from the center is C. A and B are the vertices of this ellipse. Then clearly F1 equals to minus C0 because this focus lies on the negative x-axis, while as F2 equals to C0 because it is on the positive side of x-axis. Here B is the vertex. Then BF1 plus BF2 equals to 2A because BF1 equals to OF1 plus OB, while as BF2 equals to OB minus F OB minus OF. That is why BF1 plus BF2 equals to 2A. Now let P of xy be any arbitrary point on this ellipse. Then we will find the sum of its distances from the foci. Then Pf1 plus Pf2 equals to Bf1 plus Bf2 because by the definition distance is same for any point on the ellipse from two foci. Here Bf1 plus Bf2 we calculated it to be 2a, that is why Pf1 plus Pf2 equals to 2a. So it is by the definition of ellipse. Now here coordinates of P or xy, coordinates of F1 or minus C0, coordinates of F2 or C0. So we will calculate this Pf1 and Pf2 by using the distance formula. That is why Pf2 equals to root of x square minus c x minus c का whole square plus y square, while as Pf1 equals to root of x plus c whole square plus y square because in F1 c is negative. Substituting in this, we get root of x minus c whole square plus y square plus root of x plus c whole square plus y square is 2a. So on squaring this equation, that is this, and after simplifying, we simply get x square upon a square plus y square upon a square minus c square equals to 1. Name it equation second. But in my last video lecture, we derived a relationship between the major axis, semi-major axis, semi-minor axis, and the distance of one of the foci from the center. And we know that c square equals to a square minus b square is the required relation. So substituting c square in this equation here in the denominator of y square, we simply get x square upon a square plus y square upon a square minus a square plus b square equals to 1, which implies that x square upon a square plus y square upon b square equals to 1. So this means that when a point P of xy lies on the ellipse, then it satisfies this very equation. Here A is the semi-major axis and this major axis lies on x-axis. So this means that here the denominator of x square is the square of semi-major axis, while as denominator of y square is length of semi-minor axis, and this semi-minor or the minor axis lies on this y axis. Now conversely assume that this Conversely, assume that P of x by any point satisfies this very equation, that is x square plus a square plus y square upon b square equals to 1. We have to prove that this point lies on the ellipse. Assume that P of xy satisfies this very equation, that is x square upon a square plus y square upon b square equals to 1. Then from this y square equals to b square into 1 minus x square upon a square, where this c is less than a. Here f1, the focus of an ellipse, is minus c0, f2 equals to c0, then p of f1 equals to a plus c by ax using b square equals to a square minus c square. Similarly, p f2 equals to a minus c upon ax. Then their sum, that is p f1 plus p f2, is 2a. Now if b is the vertex of an ellipse whose major axis is x-axis, then its coordinates are b0, sorry, a0, then clearly bf1 plus bf2 equals to 2a. Hence, by definition, this distance, sum of the distance of any point from two fixed points, is constant and is same. This means that all those points form ellipse or they lies on the ellipse. Hence, when the point P satisfies x square upon a square plus y square upon b square equals to 1, then it lies on the ellipse. Hence, from this we conclude that the standard form of the ellipse whose major axis is on x-axis and minor axis is on y-axis is x square upon a square plus y square upon b square equals to 1. Here major axis lies on this x-axis, which implies that a is always greater than b. This means that the denominator of x square is always greater than the denominator of y square. Similarly, if the major axis lies on the y-axis, this means that the foci lies on the y-axis. Their coordinates are 0 c and 0 minus c, that is this very. Vertices are a0 and minus 0 minus a. Length of the major axis is 2a, which is greater than the length of the minor axis, which lies on the x-axis, which is smaller than the major axis. Using c square equals to a square minus b square, equation of such very ellipse is x square upon b square plus y square upon a square equals to 1. Here this denominator of y square is greater than the denominator of x square. So simply, if we have an equation containing x square and y square such that the denominator of x and this y square is greater than the denominator of y square, then we simply say that it is an ellipse whose major axis is on y-axis or lies on y-axis. Now if the denominator of x square is greater than the denominator of y square, then we simply say that the major axis is on the x-axis, that is the foci lies on the x-axis. Like if we consider x square upon 9 plus y square upon 4 equals to 1, here denominator of x square is greater than the denominator of this y square, which implies that here 9 can be written as 3 square, 4 can be written as 2 square. This means that its form is, it represents a parabola. This parabola, that is this major axis is 3, semi minor axis is 2, because a and b are the semi major and the semi minor axis respectively. Vertices are 30 and minus 30 because it is on the major axis. This major axis is on the x-axis. Like if we consider x square upon y square, x square upon 4 plus y square upon 25 is 1. This means that a equals to 2 because 4 is 2. Sorry, this b equals to 2 because in this denominator of x square is less than the denominator of this y square. So least denominator is written in the form of b, that is it represents b square, which implies that here b square is 4, b is 2, a is 5. This means that its form is, it represents this very ellipse. Foci lies on y-axis, that is major axis is y-axis, and its length is 20, 10, that's 2a, whereas semi major axis is 5. Vertices are 0, 5 and 0, minus 5. So in this way we derived the standard forms of ellipse. Now here we have usually two forms, this form and this form. This very form where the major axis is in y-axis and where the major axis is x-axis. Then these two forms, both forms are symmetric about x-axis as well as y-axis. So this means that ellipse is symmetric about, always symmetric about x as well as the y axis. So inshallah in tomorrow's video lecture we will do some problems about standard forms to find the form of an ellipse with given conditions. So thank you.